Hello, my dear students. In this class, we will learn high-speed train system. China has a widely diverse land use, terrain, and climate, facing congested passengers, freight rail conditions. China chose to invest in capacity improvements on the existing railway system. The development and a dedicated high-speed train network connecting the major population centers. An influential symbol of China's fast development, interconnected and technical power is high-speed train. China had built at least 34 lines of the high-speed rail globally, a network exceeding 20,000 kilometers and covered 160 cities. China has built 5,000 kilometers. Pacific China HSR that connects Kunming in China to Singapore and other countries. Asia needs to spend $40 trillion on infrastructure by 2020. And high-speed train is the crown jewel of China's infrastructure export. Now, let's look at high-speed train system history. The first high-speed train line segment in China opened in 2003 between Qinhuangdao and Shenyang. The 405-kilometer segment operates at a speed of 200 kilometers per hour, is now a part of a 6,299 kilometers network of high-speed rail lines. The 120 kilometers Beijing to Tianjin segment that operated in 2008 signifies China's first ultra-fast high-speed rail operation. The longest and most complicated Wuhan to Guangzhou line. It is a part of the Beijing-Guangzhou-Shenzhen-Hong Kong route, opened in 2009. The first high-speed train built on a collapsible loss area, Zhengzhou to Xi'an road, opened in 2010. The first high-speed train built on a high-latitude area, Harbin to Dalian road, opened in 2012. Types of high-speed railway service. G-class trains run at higher speed, at a top speed, and at least 250 kilometers per hour. The G7 train from Beijing south to Shanghai, Hongqiao average 300 kilometers per hour. G-class trains run on the high-speed tracks and typically serve long-distance trips. D-class trains run at a lower speed and can vary widely in actual trip speed. D-class trains have distributed power system and run on regular tracks between major cities, and earlier generation D-class trains have a maximum speed of 200 to 250 kilometers per hour. C-class trains also operate on a high-speed track at speeds over 250 kilometers per hour. C-class trains on the Beijing to Tianjin reach top speed of 330 kilometers per hour and average 226 kilometers per hour for the trip. The maglev hovers several centimeters above the tracks. It is propelled by electrically charged magnets and uses specially designed tracks to keep the trains from overturning and derailing. China's first medium-low-speed maglev line with maximum speed of 100 kilometers per hour start operation in May in 2016 in Changsha. The Shanghai Maglev is currently the world's fastest commercially operating train, routinely zipping back and forth between the city and Pudong International Airport at 430 kilometers per hour. The 30 kilometers journey takes less than 8 minutes. Some maglev train lines cost run beyond budget. The commercially viability of maglev is in question. The price tag of the Shanghai maglev was believed to be 1.3 billion and was partially financed by the German government. For vertical and for horizontal networks in China, the central piece of China's Ministry of Railways expansion into high-speed rail is a national high-speed rail grid that is overlaid onto the existing railway network. The grid is composed of 8 high-speed rail corridors, 4 running north-south and 4 east-west, and has a total of 12,000 kilometers. In 2016, the National Development and Reform Commission announced the plans to extend most completed 4 vertical and 4 horizontal network to a new 8 vertical and 8 horizontal network. The new network comprises 8 north-south corridors and 8 east-west ones, almost doubling the route length. How does China achieve this objective? Chinese government support. High-speed train developed rapidly in China over the past 15 years. It is thanks to the generous funding from China government, especially the Economic Stimulus Program during the Great Recession. Foreign technology transfer. Chinese engineers, after receiving transferred foreign technology, have been able to develop indigenous capability to reduce key parts and improving upon foreign designs. Spillover effects. Technological and social-economic spillover effects brought about wide benefits and further scaled up high-speed train. Huge investments. When the 2008 financial crisis hit the US and China, China made use of the opportunity to do the opposite by investing heavily in infrastructure building in order to stimulate economy and create jobs. Approximately 45 investments focused on the transport and power infrastructure. A numerous investment in this area leads to the rapid development of a high-speed rail network and properly boom in recent several years. High-speed train experienced the fastest growth during this period. The leadership. The strong political will of Chinese leaders to do this thing on a grand scale and to complete projects quickly is the major contributing factor. This factor speeds up China's high-speed train development. China is able to benefit from economy of scale and economy of standardization in railway construction. The fine division of labor and mass production have cut down the cost of many items of technology given China, added average to developing high-speed train. To develop the high-speed railway technology almost from scratch with the introduction of foreign technology, China has been able to mobilize the resources of 25 leading universities, 11 science academies, 51 national laboratories, 500 companies, and 40 government research. The unit cost of China's high-speed railway infrastructure of about 17 to 21 million per kilometer. while the comparable cost in Europe is 25 to 39 million per kilometers. As to the cost of building railway tunnels, it is about 10 to 15 million per kilometer in China. It is 15 million per kilometer in the US and 16 per kilometer in Australia. The effect of the developing high-speed train. Urban agglomeration. 3 major urban agglomerations in China, south, east, north, has emerged in social-economic development. These are Jing-Jin-Ji in the north, Yangtze River Delta in the east, and Pearl River Delta in the south. China has approved a 36 million railway plan to improve transport links between the capital Beijing, the port city of Tianjin, and a neighboring province of Hebei. Yangtze River Delta is well connected with the famed high-speed rail Beijing-Shanghai and Shanghai-Hangzhou, part of the Hangzhou-Fuzhou-Shenzhen high-speed railway. Pearl Rail Delta, which was the nearest test field of the reform and opening up, is connected by its 150-kilometer Guangzhou to Shenzhen Hong Kong Express rail link. Advent of high-speed railway in China has greatly reduced the travel time and has transformed Chinese society. The network rapid expansion means that 29 of China's 31 provinces and regions are connected by the bulletin trains. Changing travel mode. More Chinese people are choosing to ride rather than fly. This is because train terminals tend to be located closer to the city center, and unlike the airports, security screens and check-in process are much speedier. High-speed railway is also like a scaled-up subway system serving the whole country. Western development. The high-speed train industry comprises several sectors and has a spillover effect in China industry, upgrading and economic restricting. It will give a far-reaching impact on economic development and economical backward western part of the country. It only takes about 5 hours to travel from Beijing to Xi'an by high-speed train, compared with more than 11 hours by normal speed train. Scale Road. China's high-speed railway program is crossing borders. The expansion of the high-speed railway network will provide a boost to development plans of the West China. It will facilitate the extension of China's economic links with its northern and western neighbors countries, and create an alternative region market that can offset the impact of the recession or downturn in the big trading power. Overseas exports. China high-speed trains have been sold to 102 countries and regions. $18 million worth of high-speed related agreements were signed in 2016, a 40% increase from 2015. In 2015, China outbid Japan to win a $4.5 billion project in Indonesia. Okay, that's all for today's class, and thank you for joining us. I'll see you next time.